Question 1. Which diagram best represents the solution set of x squared minus 2x minus 3 greater than or equal to 0? This question may be solved geometrically. X squared minus 2x minus 3 represents a concave up parabola, and the x-intercepts may be found by solving the quadratic equation x squared minus 2x minus 3 equals 0. For factorising the left-hand side, we have x minus 3 in brackets multiplied by x plus 1 in brackets equals 0, so therefore x equals negative 1 or 3. Now we want the values of x where the parabola y equals x squared minus 2x minus 3 is at or above the x-axis. So here is a sketch that represents the parabola y equals x squared minus 2x minus 3, intersecting with the x-axis at x equals negative 1 and 3. And the shaded region here and here represents the part of the parabola that's at or above the x-axis. And that occurs when x is less than or equal to negative 1 or greater than or equal to 3. So therefore, the answer is option A. Question 2. Given f of x equals 1 plus the square root of x, what are the domain and range of the inverse of f of x? The domain and range of f of x are swapped for the inverse of f of x. And in this case, the domain of f of x is x greater than or equal to 0. The range of f of x is y greater than or equal to 1. Therefore, the domain of the inverse of f of x is x greater than or equal to 1. And the range of the inverse of f of x is y greater than or equal to 0. Therefore, the answer is option C. Question 3. Which of the following is an antiderivative of 1 over 4x squared plus 1? Recall that the derivative of the inverse tan of f of x is equal to 1 over f of x all squared plus 1 multiplied by the derivative of f of x according to the chain rule. In this case, f of x is equal to the square root of 4x squared, which equals 2x, and the derivative of f of x equals 2. Hence, the derivative of the inverse tan of 2x is equal to 2 over 4x squared plus 1. Multiplying both sides of the equation by half, we get the derivative of the inverse tan of 2x multiplied by half is equal to 1 over 4x squared plus 1, which equals the original expression. Therefore, working backwards, the antiderivative of 1 over 4x squared plus 1 is equal to the inverse tan of 2x multiplied by half plus c. Therefore, the answer is option D. Question 4. Maria starts at the origin and walks along all of the vector 2i plus 3j, then walks along all of the vector 3i minus 2j, and finally along all of the vector 4i minus 3j. How far from the origin is she? The distance from the origin may be found by summing the three vectors and then applying Pythagoras' theorem. In each vector, the letter I represents movement in the horizontal direction and the letter j in the vertical direction. Consider the movement in the horizontal direction. 2i plus 3i plus 4i can be interpreted as 2 units to the right plus 3 units to the right plus 4 units to the right, which equals 9 units to the right. Consider movement in the vertical direction. We have 3j minus 2j minus 3j, which can be interpreted as 3 units up plus 2 units down plus 3 units down, which equals 2 units down. Representing these two values on a right angle triangle, we have the two short sides, 9 units to the right and 2 units down, and applying Pythagoras' theorem, x squared is equal to 9 squared plus 2 squared, which equals 85, so therefore x equals the square root of 85. Hence the answer is option B. Question 5. A monic polynomial p of x of degree 4 has one repeated 0 of multiplicity 2 and is divisible by x squared plus x plus 1. Which of the following could be the graph of p of x? Firstly, the divisor x squared plus x plus 1 has no real roots. This fact, alongside the fact that the polynomial p of x has one repeated 0 of multiplicity 2, means options B and D are both incorrect. Secondly, p of x is monic. In other words, it can be written as x to the power of 4 plus bx cubed plus cx squared and so on. So x to the power of 4 is the dominant term. So as x approaches infinity or x approaches negative infinity, p of x, or the y value, approaches infinity. So that means that the direction of the curve at either end should be upwards. Therefore, option A is incorrect since at either end of the curve, the arrows are pointing downwards. So therefore, the answer is option C. Question 6. The vectors A and B are shown. Which diagram below shows the vector V equals vector A minus vector B? Vector V may be found by taking vector A and adding the negative of vector B. Here is a diagram that shows that situation. So here's vector A, and here's vector negative B. So it's just vector B where the arrow has changed direction. So it's pointing this way instead of down this way. And vector V is just the sum of vector A and vector negative B. So it's just drawn from the start of vector A to the end of vector negative B. And the diagram that corresponds to that is option D. So therefore, the answer is option D. Question 7. Which of the following best represents the direction field for the differential equation dy dx equals negative x over 4y? X is the numerator of the differential equation. So when x equals 0, dy dx equals 0 for all y not equal to 0, since y is the denominator and we cannot have a division by 0. So what this is saying is that along the y-axis, the gradient of the arrows should be 0, or horizontal in direction. So option C and option D are both incorrect. When x is less than 0 and y is greater than 0, so in other words, we're focusing on quadrant 2, in these two options, dy dx is greater than 0, since we have negative x, or negative of a negative number, which makes it positive, over a positive denominator, and that makes the derivative dy dx positive, which means that the direction of the arrows, or the gradient of the arrows, should be positive, which means option B will be incorrect since some of the arrows have a negative direction or a negative gradient. So by the process of deductive reasoning, the answer is option A. Question 8. Out of 10 contestants, 6 are to be selected for the final round of a competition. 4 of those 6 will be placed first, second, third, and fourth. In how many ways can this process be carried out? We may describe this situation as a two-stage arrangement. Stage 1 involves an unordered arrangement where 6 people are chosen from 10, and stage 2 involves an ordered arrangement where out of the 6 people chosen, we're going to choose 4 people and then rank them first, second, third, and fourth. Now the number of arrangements for stage 1 is equal to 10 choose 6. I'm going to use combinations since order does not matter. And the number of arrangements for stage 2 is equal to 6p4 using permutations since order is important. Now by the fundamental counting principle, the total number of arrangements is equal to 10 choose 6 multiplied by 6p4. And using factorial notation, 10 choose 6 is 10 factorial over 4 factorial 6 factorial multiplied by 6 factorial over 2 factorial, which represents 6p4. Now the 6 factorial in the numerator here will cancel with the 6 factorial in the denominator here, and we end up with 10 factorial over 4 factorial 2 factorial. Therefore, option C is the answer. Question 9. The projection of the vector 6i plus 7j onto the line y equals 2x is 4i plus 8j. The point 6, 7 is reflected in the line y equals 2x to a point A. What is the position vector of the point A? This question may be answered geometrically. Let OC represent the vector 6i plus 7j, and it's projected onto the line y equals 2x, such that the vector that represents the projection is the vector 4i plus 8j. Looking at it from the point of view of coordinate geometry, the endpoint of vector OC has coordinates 6, 7, And the endpoint of vector OB, which is the projection of OC onto the line y equals 2x, has coordinates 4, 8. Now point C is reflected in the line y equals 2x to a point A, such that the distance from point C to point B is equal to the distance from point B to point A, and the gradient AC is perpendicular to the line y equals 2x. The horizontal distance from point C to point B is equal to the horizontal distance from point B to point A. So the x-coordinate of point C is 6, the x-coordinate of point B is 4, 6 minus 4 is 2, so the horizontal distance from C to B is 2 units. Subtracting 2 from 4, and that equals 2. That means that the distance in the horizontal direction from point B to point A is also 2 units, so 4 minus 2 is 2, so the x-coordinate of point A is 2. Looking at it from the vertical direction, the vertical distance from point C to point B is 1 unit, so 7 to 8, which means that the vertical distance from point B to point A is equal to the vertical distance from point C to point B. So adding 1 to 8, that equals 9. So the coordinates of point A is 2, 9, which means the vector that joins the origin to point A is 2i plus 9j. Therefore, the answer is option B. Question 10. The quantities P, Q, and R are connected by the related rates dr dt equals negative k squared, dp dt equals negative l squared multiplied by dr dt, and dp dt equals m squared multiplied by dq dt, where k, l, and m are non-zero constants. Which of the following statements is true? Firstly, negative k squared is less than 0, since any non-zero number squared is greater than 0, and then multiplying that by negative 1 will make that negative. Therefore, dr dt is less than 0. The next point is that negative l squared, for the same reason, is less than 0. Hence, dp dt is equal to a negative quantity multiplied by another negative quantity, which makes dp dt a positive quantity. So dp dt is greater than 0. Lastly, m squared is greater than 0. Again, for a similar reason to the previous two reasons, we just have a number squared, which is obviously positive. Now, dp dt is positive from this point here, and that's equal to a positive quantity multiplied by dq dt. So dp dt divided by m squared, so a positive quantity, divided by another positive quantity, equals a positive quantity. Therefore, dq dt is greater than 0. Hence, dp dt is increasing and dq dt is increasing. Therefore, the answer is option A. Question 11a. Let p of x equal x cubed plus 3x squared minus 13x plus 6. Part 1. Show that p of 2 equals 0. Substituting x equals 2 into the polynomial, we have p of 2 equals 2 to the power of 3 plus 3 multiplied by 2 to the power of 2 minus 13 multiplied by 2 plus 6, and that equals 8 plus 12 minus 26 plus 6, and that equals 0. So therefore, p of 2 equals 0 as required. Part 2. Hence, factor the polynomial p of x as a of x multiplied by b of x, where b of x is a quadratic polynomial. From part 1, since p of 2 equals 0, by the factor theorem, x minus 2 is a divisor of p of x. So apply polynomial long division to find b of x. So we're going to divide x cubed plus 3x squared minus 13x plus 6 by x minus 2. So applying the process of polynomial long division, x into x cubed goes x squared times x squared multiplied by x minus 2 is equal to x cubed minus 2x squared, and x cubed plus 3x squared minus x cubed minus 2x squared is equal to 5x squared, and then we write negative 13x behind 5x squared. And we repeat the process again. X into 5x squared goes 5x times 5x multiplied by x minus 2 is 5x squared minus 10x. And subtracting these two terms from these two terms, we get negative 3x, and then we write the plus 6 after the negative 3x, and repeat the process one more time. x into negative 3x goes negative 3 times. Negative 3 multiplied by x minus 2 is negative 3x plus 6. And negative 3x plus 6 minus negative 3x plus 6 is equal to 0. So there's no remainder. Hence, b of x is equal to x squared plus 5x minus 3. And therefore, p of x can be written as p of x equals x minus 2 in brackets multiplied by x squared plus 5x minus 3. Question 11b. For what values of a are the vectors ai minus j and 2a minus 3i plus 2j perpendicular? Apply the formula for the dot product. That is, vector a dot vector b is equal to the magnitude of vector a multiplied by the magnitude of vector b multiplied by the cosine of the angle between vectors a and b. If vector a is perpendicular to vector b, then theta is equal to 90 degrees. Hence, cos of 90 degrees is equal to 0. So going back to the dot product formula, that means vector a dot vector b is equal to the magnitude of vector a multiplied by the magnitude of vector b multiplied by 0. So that implies that the left-hand side, this vector a dot vector b, is equal to 0. So we need to solve the equation aiaj dot bibj, where aiaj is the first vector and bibj is the second vector, is equal to 0 for a. So if we multiply the rows together, we have a multiplied by 2a minus 3 minus the product of the second row, which is aj multiplied by bj, which is negative 2, and that equals 0. So expanding the left-hand side, we get 2a squared minus 3a minus 2 equals 0. And factorising the left-hand side, we get 2a plus 1 in brackets multiplied by a minus 2 in brackets equals 0. Hence, a is equal to negative half, or 2. So therefore, the vectors are perpendicular if a is equal to negative half, or 2. Question 11c. The diagram shows the graph of y equals f of x. Sketch the graph of y equals 1 over f of x. The first point to note is the location of the vertical asymptotes, and they occur at x equals plus or minus 2. And that's because the graph of the original function has x-intercepts at negative 2 and 2, and the y value at the x-intercepts is 0, and the reciprocal of 0 is undefined. Hence why there are vertical asymptotes at x equals plus or minus 2. And that's the first thing drawn. The next point to note is the location of the y-intercept of the graph of y equals 1 over f of x. Now in the original graph, the y-intercept is negative 3, and the reciprocal of negative 3 is negative 1 over 3. So the graph of 1 over f of x will pass through the point 0, negative a third, and that's marked on the graph. The last point to note is the location of the horizontal asymptote. Now, considering the graph of the original function, as x approaches infinity or negative infinity, the y value, or f of x, approaches infinity. Hence, as the y value gets larger, the reciprocal of that gets smaller. So as x gets larger, or approaching infinity or negative infinity, y equals 1 over f of x will approach 0. Hence, the horizontal asymptote is y equals 0, which is the x-axis. Now, the last point to consider is the reciprocal of a positive is a positive, and the reciprocal of a negative is a negative. And hence why the graph is drawn the way it is, considering all these other points. Question 11d. By expressing the square root of 3 sine x plus 3 cos x in the form a sine x plus alpha, solve the square root of 3 sine x plus 3 cos x equals the square root of 3 in the interval x greater than or equal to 0 and less than or equal to 2 pi. The first step is to find the values of a and alpha in the identity a sine x plus alpha is identical to the square root of 3 sine x plus 3 cos x. Expanding the left-hand side, since we have the sine of a compound angle, we have a outside of sine x cos alpha plus sine alpha cos x is identical to the square root of 3 sine x plus 3 cos x. Expanding the left-hand side further and switching the sine x and the cos alpha around, we have a cos alpha sine x plus a sine alpha cos x is identical to the square root of 3 sine x plus 3 cos x. So I just wanted the terms involving alpha to be written first. Now, equating the coefficients of sine x and cos x, we have a cos alpha is equal to the square root of 3, and a sine alpha is equal to 3, since a cos alpha is the coefficient of sine x, and that should equal the coefficient of sine x on the right-hand side, which is the square root of 3. And likewise for the coefficient of cos x. So we can write that as two equations. A cos of alpha is equal to the square root of 3, and call that equation number 1. And a sine of alpha is equal to 3, and we'll call that equation number 2. Now, to find the value of a, we square both equations and add them together. So equation 1 squared plus equation number 2 squared. So we have a squared cos squared alpha plus a squared sine squared alpha is equal to the square root of 3 all squared plus 3 squared. Factorising a squared, on the left-hand side, we have a squared outside of cos squared alpha plus sine squared alpha is equal to 12. And we have a Pythagorean identity here, and that's equal to 1. Hence, a squared is equal to 12. I'm taking the square root of both sides when we're only interested in the positive square root. A is equal to 2 square root of 3. And we'll call that number 3 there. Now, to find the value of the auxiliary angle alpha, we take equation number 2 and divide it by equation number 1, because that'll cancel out the a, and we end up with a term involving tan of alpha. So a sine of alpha over a cos of alpha is equal to 3 over the square root of 3. The a's cancel, and we end up with tan of alpha is equal to the square root of 3. And taking the inverse tan of both sides, we have alpha is equal to 60 degrees, or pi over 3 radians, but we're working in radians, so pi over 3 is the value of alpha. Now to solve the equation, a sine of x plus alpha is equal to the square root of 3. Now that we have the values of a and alpha. So a is equal to 2 root 3 and alpha is equal to pi over 3. So substituting those two values for a and alpha, we have 2 square root of 3 sine of x plus pi over 3 is equal to the square root of 3. So now we just solve for x. Dividing both sides by 2 root 3, we have sine of x plus pi over 3 is equal to half. X plus pi over 3 is equal to the inverse sine of half, and inverse sine of half is pi over 6, or 30 degrees, but we work in radians in this question. So that means that x plus pi over 3 is equal to pi over 6, 5 pi over 6, 13 pi over 6, and so on. And this gives rise to two cases, since we're only working in the interval x greater than or equal to 0 or less than or equal to 2 pi. So pi over 3 needs to be subtracted from these values such that the value of x needs to be in the interval that I just stated. So case 1, we can take 5 pi over 6 and we subtract pi over 3 from that to make x the subject of the formula, and we get the value of x equal to pi over 2. And case number 2, x is equal to 13 pi over 6 minus pi over 3, and x equals 11 pi over 6. So therefore, the solution is x equals pi over 2 or 11 pi over 6 radians. Question 11e. Solve dy dx equals e to the power of 2y, finding x as a function of y. The first step is to take the reciprocal of both sides of the differential equation, since we want to find x as a function of y. Hence, dx over dy is equal to 1 over e to the power of 2y, which equals e to the power of negative 2y, expressing the right-hand side with a negative index. Multiplying both sides by the differential dy, we have dx is equal to e to the power of negative 2y dy. Integrating both sides of that equation, we have the integral of dx is equal to the integral of e to the power of negative 2y dy. Now the integral of dx is x, and the integral of e to the power of negative 2y with respect to y is e to the power of negative 2y over negative 2 plus c. And simplifying this equation, we have x is equal to negative half multiplied by e to the power of negative 2y plus c. Question 12a. Use the principle of mathematical induction to show that for all integers n greater than or equal to 1, 1 multiplied by 2 plus 2 multiplied by 5 plus 3 multiplied by 8 plus ... plus n multiplied by 3n minus 1 equals n squared multiplied by n plus 1. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can choose is n equals 1. From the left-hand side, we have 1 multiplied by 2, which equals 2. And from the right-hand side, we have 1 squared multiplied by 1 plus 1, which also equals 2. Left-hand side equals right-hand side, hence the statement is true for n equals 1. The next step is to assume the statement is true for n equals k. That is 1 multiplied by 2 plus 2 multiplied by 5 plus dot 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 plus k multiplied by 3k minus 1 is equal to k squared multiplied by k plus 1. And I've labelled this line with an asterisk. The next step is to show the statement is true for n equals k plus 1. From the left-hand side, we have 1 multiplied by 2 plus 2 multiplied by 5 plus dot 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 plus k multiplied by 3k minus 1 plus k plus 1 multiplied by 3 outside of k plus 1 minus 1. And that equals k squared multiplied by k plus 1 plus k plus 1 multiplied by 3k plus 2. And that's from the assumption. So we can replace this part of the left-hand side with k squared multiplied by k plus 1, and simplifying k plus 1 multiplied by 3 outside of k plus 1 minus 1, which is k plus 1 multiplied by 3k plus 2. Factorising out k plus 1, left-hand side is equal to k plus 1 outside of k squared plus 3k plus 2. And factorising this monic quadratic, we have left-hand sides equal to k plus 1 multiplied by k plus 1 multiplied by k plus 2. And that equals k plus 1 all squared multiplied by k plus 2. And that equals n squared multiplied by n plus 1 since n equals k plus 1. And that equals the right-hand side of the original statement. To conclude, the statement is true for n equals 1 and n equals k plus 1. Hence, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1. Question 12b. When a particular biased coin is tossed, the probability of obtaining a head is 3 over 5. This coin is tossed 100 times. Let x be the random variable representing the number of heads obtained. This random variable will have a binomial distribution. Part 1. Find the expected value, e of x. E of x is the relative frequency of obtaining heads from 100 tosses. In this case, e of x is equal to 100 multiplied by 3 over 5, which equals 60. Part 2. By finding the variance, var of x, show that the standard deviation of x is approximately 5. The variance of x is given by the formula np multiplied by 1 minus p, where n is the number of trials and p is the probability of success. And in this case, n is equal to 100 and p is equal to 3 over 5. So var of x is equal to 100 multiplied by 3 over 5 multiplied by 2 over 5, which is 1 minus p. And that equals 24. Therefore, the standard deviation is the square root of the variance, so it's the square root of 24, which is approximately 5. Part 3. By using a normal approximation, find the approximate probability that x is between 55 and 65. Using the z-score formula, the z-score corresponding to 55 is equal to 55 minus 60 divided by 5, where 55 is the raw score, 60 is the expected value, and 5 is the standard deviation, and that equals -1. The z-score corresponding to 65 is equal to 65 minus 60 in brackets divided by 5, and that equals 1. Hence, the probability that x lies between 55 and 65 is equal to the probability that z lies between -1 and 1, and that equals 68% by the empirical rule. Question 12c. To complete a course, a student must choose and pass exactly 3 topics. There are 8 topics from which to choose. Last year, 400 students completed the course. Explain, using the Pigeonhole principle, why at least 8 students passed exactly the same 3 topics. Firstly, we'll consider the number of ways a student can choose 3 topics from the 8. Now this is an unordered selection, so we'll use combinations to determine this. 8 choose 3 is equal to 56 combinations. So there are 56 different ways a student can choose 3 topics from the 8. Next, we'll consider the 400 students who passed a course, and a course consists of 3 topics. Now, the 400 students divided evenly over the 56 different combinations is equal to 7 and 1 over 7 students per unique combination. But the number of students who chose a particular combination must be an integer. This value here doesn't make sense since we're talking about a whole number of students. Now 7 and 1 over 7 is greater than 7. Hence, by the pigeonhole principle, at least 8 students must have passed the same combination of 3 topics. Question 12D. Find the integral from x equals 0 to x equals pi over 2 of cos of 5x multiplied by sine of 3x dx. The first step is to convert the product cos of 5x sine of 3x to a sum. Let a equal 5x and b equal 3x. Sine of a plus b minus sine of a minus b is equal to sine a cos b plus sine b cos a minus, in brackets, sine a cos b minus sine b cos a, close brackets. Expanding the brackets, that equals 2 sine b cos a, since sine a cos b and this sine a cos b will cancel. Hence, cos a sine b is equal to half outside of sine of a plus b minus sine of a minus b. Now substituting 5x for a and 3x for b, cos of 5x sine of 3x is equal to half outside of sine of 8x minus sine of 2x. Now half the integral from x equals 0 to x equals pi over 2 of sine of 8x minus sine of 2x dx is equal to half outside of negative cos of 8x over 8 plus cos of 2x over 2 from x equals 0 to pi over 2. Applying the limits of integration, that equals half outside of negative cos of 4 pi over 8 plus cos of pi over 2 minus half outside of negative cos of 0 over 8 plus cos of 0 over 2. And that equals half outside of negative 1 over 8 minus 1 over 2 minus half outside of negative 1 over 8 plus 1 over 2. And that equals negative 1 over 2. Question 12e. Find the curve which satisfies the differential equation dy over dx is equal to negative x over y and passes through the point 1, 0. This is a separable differential equation. Starting with dy over dx is equal to negative x over y and applying cross multiplication, the variables may be separated. And we get y dy is equal to negative x dx. Integrating both sides, so the integral of y dy is equal to negative the integral of x dx, we obtain half of y squared is equal to negative half of x squared plus the constant c. Moving the negative half of x squared over to the other side by adding half of x squared to both sides, we get half of y squared plus half of x squared is equal to the constant c. Multiplying both sides by 2 to eliminate the fraction, we get x squared plus y squared is equal to the constant d, where d is equal to 2c. Now the curve passes through the point 1, 0, and we can use that fact to find a value for d. So substituting x equals 1 and y equals 0 into this equation, we get 1 squared plus 0 squared is equal to d, hence d equals 1. Therefore, the curve which satisfies the differential equation dy over dx equals negative x over y, passing through 1, 0, is the unit circle x squared plus y squared equals 1. Question 13a, Part 1. Find the first derivative with respect to theta of sine cubed theta. Sine cubed theta is equivalent to sine theta all cubed. Hence, by the chain rule, d theta of sine theta all cubed is equal to 3 sine squared theta multiplied by d theta of sine theta, so that's the derivative of the outside multiplied by the derivative of the inside. And that equals 3 sine squared theta multiplied by cos theta, which equals 3 sine squared theta cos theta. Part 2. Use the substitution x equals tan theta to evaluate the integral from x equals 0 to x equals 1 of x squared over 1 plus x squared in brackets to the power of 5 over 2 dx. The substitution is x equals tan theta. So that means anywhere we see x in the integral, we're going to replace that with tan theta. Also, dx d theta is equal to sec squared theta. Multiplying both sides by d theta to make dx the subject of the formula, we get dx is equal to sec squared theta d theta. And the right hand side will replace the dx in the integral. Hence, we can write the integral in terms of tan theta and replace the dx with sec squared theta d theta. And it will look like the integral of tan squared theta over 1 plus tan squared theta to the power of 5 over 2 multiplied by sec squared theta d theta. Note that 1 plus tan squared theta is equal to sec squared theta, and this is one of the Pythagorean identities. So this equals the integral of tan squared theta multiplied by sec squared theta over sec squared theta to the power of 5 over 2. So we replace the 1 plus tan squared theta with sec squared theta, and that's with respect to theta. And simplifying this fraction, we get the integral of tan squared theta over sec cubed theta d theta. And this equals to sine squared theta over cos squared theta, so that's equivalent to tan squared theta, divided by sec cubed theta, which is 1 over cos cubed theta d theta. And that equals the integral of sine squared theta cos theta d theta. And this resembles the answer to part 1. Now to work out the limits of integration, since we've substituted theta for x. So when x equals 0, using the substitution, x equals tan theta, theta is equal to 0. And when x equals 1, solving for theta, we get theta is equal to pi over 4. And that can be found by substituting x equals 0 and then solving for theta, and x equals 1 and solving for theta. Now, to make the integrand look like the solution to part 1, we multiply the integrand by 3, but then we compensate by multiplying by 1/3 outside of the integral. So the integral becomes 1/3 multiplied by the integral of 3 sine squared theta cos theta d theta from theta equals 0 to pi over 4. And this equals 1 over 3 multiplied by sine cubed theta from theta equals 0 to pi over 4. And applying the limits of integration, we get 1/3 multiplied by the square root of 2 over 2 to the power of 3. And that equals 1/3 multiplied by 2 root 2 over 8. And that equals the square root of 2 over 12. Question 13b. The region R is bounded by the y-axis, the graph of y equals cos of 2x, and the graph of y equals sine of x, as shown in the diagram. Find the volume of the solid of revolution formed when the region R is rotated about the x-axis. The first step is to find the x-coordinate that corresponds to the point of intersection of the two curves. And we do that by solving the equation sine x equals cos 2x. Now cos 2x can be converted into an equivalent trigonometric function involving sine. And cos 2x is also a double angle. So we've got a double angle here and a single angle here. So we need to form an equation that uses the same trig function, but also the same angle as well. Now, cos 2x is equivalent to 1 minus 2 sine squared x. So that's from one of the double angle formulae. So sine of x is equal to 1 minus 2 sine squared of x after we substitute 1 minus 2 sine squared of x for cos of 2x in this equation here. And moving everything on the right-hand side to the left-hand side, we form a quadratic equation. So 2 sine squared x plus sine x minus 1 equals 0. Factorising the left-hand side, we get 2 sine x minus 1 in brackets multiplied by sine x plus 1 in brackets equals 0. And we're only interested in values of x that are greater than 0. So we only need to solve this bracket here. 2 sine x minus 1 equals 0. So adding 1 to both sides, we get 2 sine x equals 1. Dividing both sides by 2, we get sine x equals half, hence x equals pi over 6. Now the volume is equal to pi multiplied by, it's all in brackets of course, pi multiplied by the integral from x equals 0 to pi over 6 of cos squared 2x dx, minus the integral from x equals 0 to pi over 6 of sine squared x dx. So to integrate this, we need to convert the cos squared and the sine squared into equivalent trigonometric functions that have a power of 1 or an index of 1. Now cos 2x is equal to 2 cos squared x minus 1. If we double the angle on both sides, so double 2x is 4x and double x is 2x, we end up with the equation cos of 4x is equal to 2 cos squared 2x minus 1. And we can make cos squared 2x the subject of the formula because that's what we need to replace in this integral here. So cos squared 2x is equal to half outside of cos 4x plus 1. And that can be substituted for cos squared 2x in the integral here. Likewise, for sine squared x, we can substitute half outside of 1 minus cos 2x in its place. And they're definitely simpler to integrate. So the volume is pi outside of the integral from x equals 0 to pi over 6 of half outside of cos 4x plus 1 dx minus the integral from x equals 0 to pi over 6 of half outside of 1 minus cos 2x dx. And that equals pi over 2 outside of sine 4x over 4 plus x minus sine 2x over 2. So notice that the x minus sine 2x over 2 is in its own set of brackets. And the limits of integration, of course, are from x equals 0 to pi over 6. So simplifying what's inside the square brackets here and also just expanding the inner brackets here, we get the volume is equal to pi over 2 of sine 4x over 4 plus sine of 2x over 2. So this plus x and minus x here cancel. And this double negative here, so this minus minus becomes a plus here. Next, we apply the limits of integration. So that equals pi over 2 outside of sine of 2 pi over 3 over 4 plus sine of pi over 3 over 2. And these are exact ratios. So that equals pi over 2 multiplied by 1 over 4 multiplied by root 3 on 2 plus 1 over 2 multiplied by root 3 over 2. And that equals pi over 2 outside of root 3 over 8 plus root 3 over 4. And that equals pi over 2 multiplied by 3 root 3 over 8, which equals 3 pi root 3 all over 16. Question 13c. Suppose f of x equals tan of the inverse cos of x and g of x equals the square root of 1 minus x squared all over x. The graph of y equals g of x is given. Part 1. Show that f dash of x is equal to g dash of x. F of x may be differentiated by the chain rule. So f dash of x is equal to sec squared inverse cos of x multiplied by negative 1 over the square root of 1 minus x squared. And this can be written as 1 over cos squared inverse cos of x multiplied by negative 1 over the square root of 1 minus x squared. Now cos and inverse cos are inverses of each other, so that equals 1 over x squared multiplied by negative 1 over the square root of 1 minus x squared, and multiplying the two fractions together, we get negative 1 over x squared multiplied by the square root of 1 minus x squared. Now g of x may be differentiated by the quotient rule. So we have g dash of x is equal to u dash v minus uv dash over v squared, so that's the quotient rule, where u is equal to the square root of 1 minus x squared, u dash is equal to half outside of 1 minus x squared to the power of negative half, multiplied by the derivative of what's inside the brackets, which is negative 2x. And this equals negative x outside of 1 minus x squared to the power of negative half. So rather than writing it in surd form, I've left it in index form for now. V equals x, hence v dash is equal to 1. So substituting these values for u and v and u dash and v dash in the quotient rule, we get g dash of x is equal to negative x squared multiplied by 1 minus x squared to the power of negative half. So that's the u dash v, minus uv dash, which is the square root of 1 minus x squared, over v squared, which is x squared. And this equals negative 1 over the square root of 1 minus x squared. So converting this negative index here into surd form, minus the square root of 1 minus x squared over x squared, since x squared is a common denominator for both of these terms. And that equals negative x squared minus 1 minus x squared in brackets over x squared multiplied by the square root of 1 minus x squared. So this is found by finding a common denominator. So multiplying this fraction by x squared over x squared. and this fraction by the square root of 1 minus x squared over the square root of 1 minus x squared. So we have this negative x squared and a positive x squared here, negative, negative, and they cancel. So we end up with negative 1 in the numerator over x squared multiplied by the square root of 1 minus x squared in the denominator, and that equals f dash of x as required. Part 2. Using part 1 or otherwise, show that f of x equals g of x. Given f dash of x is equal to g dash of x, and this was proven in part 1, integrating both sides, we have the integral of f dash of x dx is equal to the integral of g dash of x dx. And we get the equation tan of inverse cos of x is equal to the square root of 1 minus x squared over x plus c. Now this constant is a combined constant, so each integral will generate its own constant, but they can be combined into a single constant on one side of the equation. And we need to find the value of this constant to prove that f of x equals g of x. Now from the graph, g of x intersects with the x-axis at the point 1, 0. So that's the x-intercept of the graph. So going back to the graph there, that's this point here. So this point can be substituted into the left-hand side of the equation to find the value of the constant. Hence, the square root of 1 minus x squared over x plus c equals 0 when x equals 1. Substituting x equals 1 for x here, we get 1 minus 1 squared, so 1 minus 1 is 0, square root of 0 is 0, 0 over 1 is 0 of course, so 0 plus c equals 0, hence the constant c equals 0. Therefore, f of x equals g of x as required. The following is an alternative solution based on geometric methods. Consider tan of inverse cos of x. Now, inverse cos of x represents an angle in a right angle triangle formed by the ratio adjacent over hypotenuse. So if adjacent over hypotenuse equals x, that means the adjacent side must equal x and the hypotenuse must equal 1. And I've stated that here. Inverse cos of x is equal to inverse cos of x over 1. So AB is equal to x, AC is equal to 1. Hence, by Pythagoras' theorem, side BC is equal to the square root of 1 minus x squared. Therefore, f of x equals tan of inverse cos of x, which equals BC over AB, that's opposite over adjacent, which equals to the square root of 1 minus x squared over x, which equals g of x. Therefore, f of x equals g of x as required. Question 14a, Part 1. Use the identity 1 plus x to the power of 2n equals 1 plus x to the power of n multiplied by 1 plus x to the power of n to show that 2n choose n equals n choose 0 squared plus n choose 1 squared plus ... plus n choose n squared, where n is a positive integer. By the binomial theorem, the term at position r in the expansion of 1 plus x to the power of n is given by the formula tr is equal to n choose r multiplied by 1 to the power of n minus r multiplied by x to the power of r. And it gives rise to this expansion here. So I've shown the first few terms and the last few terms of the expansion of 1 plus x to the power of n. And I've called that equation number 1. From the left-hand side of the identity, 1 plus x to the power of 2n, the term with coefficient 2n choose n, so that's the term at position n, is 2n choose n multiplied by 1 to the power of 2n minus n multiplied by x to the power of n. We'll call that equation number 2. Now from equation number 1, that can be simplified, since 1 to the power of anything is 1. We get n choose 0 plus n choose 1 multiplied by x plus n choose 2 multiplied by x squared plus ... n choose n multiplied by x to the power of n. Now 1 plus x to the power of n multiplied by 1 plus x to the power of n is really just this right hand side here multiplied to itself. And I've shown that here in 2 brackets, so I've had to split that over 2 lines. Now it's n choose 0 plus n choose 1x plus n choose 2x squared plus dot, 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 and so on, multiplied by itself. So n choose 0 plus n choose 1x plus n choose 2x squared, and so on. I'll call that equation number 3. Now from 2n choose n multiplied by 1 to the power of 2n minus n multiplied by x to the power of n. The 1 disappears, and that equals 2n choose n x to the power of n. We'll call that equation number 4. Now equating the coefficients of x to the power of n in 3 and 4, we get 2n choose n x to the power of n is equal to n choose 0 multiplied by n choose n x to the power of n plus n choose 1 x multiplied by n choose n minus 1 x to the power of n minus 1. So using fundamental index laws, x multiplied by x to the power of n minus 1 is equal to x to the power of n. And the pattern continues. So plus n choose 2 x squared multiplied by n choose n minus 2 x to the power of n minus 2. When these two terms are multiplied together, x squared multiplied by x to the power of n minus 2, we get x to the power of n. Now letting x equals 1 and using the symmetrical property of combination, so that's from Pascal's triangle, we get 2n choose n equals n choose 0 multiplied by n choose 0 plus n choose 1 multiplied by n choose 1 plus dot 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 plus n choose n multiplied by n choose n. Therefore, 2n choose n is equal to n choose 0 squared plus n choose 1 squared plus dot 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 plus n choose n squared as required. Part 2. A club has 2n members, with n women and n men. A group consisting of an even number, 0, 2, 4, dot, 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 2n, of members is chosen, with the number of men equal to the number of women. Show, giving reasons, that the number of ways to do this is 2n choose n. The club consists of n women and n men, and we want to find the number of ways of choosing an equal number of women and men, starting from 0 women and 0 men. And that's given by n choose 0 multiplied by n choose 0, which equals n choose 0 squared. Now consider the number of ways of choosing 1 woman and 1 man from n women and n men. And that's given by n choose 1 multiplied by n choose 1, which equals n choose 1 squared. Now the pattern continues in the same way right up to choosing n women and n men from n women and n men, which is n choose n squared. Hence, the total number of ways to choose an equal number of women and men is n choose 0 squared plus n choose 1 squared plus n choose 2 squared and so on, right up to n choose n squared, which equals 2n choose n, and that was proven in part 1 as required. Part 3. From the group chosen in part 2, one of the men and one of the women are selected as leaders. Show, giving reasons, that the number of ways to choose the even number of people and then the leaders is 1 squared multiplied by n choose 1 squared plus 2 squared multiplied by n choose 2 squared plus dot 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 plus n squared multiplied by n choose n squared. The number of ways of choosing 1 woman and 1 man, where the woman and the man are leaders, is given by n choose 1 multiplied by 1 multiplied by n choose 1 multiplied by 1, and that equals 1 squared multiplied by n choose 1 squared. The number of ways of choosing 2 women and 2 men, with the last woman and man chosen as leaders, is n choose 2 multiplied by 2 multiplied by n choose 2 multiplied by 2, and that equals 2 squared multiplied by n choose 2 squared. Now the pattern continues in the same way. Here is a dash diagram that represents choosing 4 women and 4 men. So these 4 dashes represent the 4 women chosen, where the last woman chosen is the leader, and also the last man chosen is also a leader. So the number of ways of choosing 4 women from n women is n choose 4, but any one of these 4 women can be a leader if they are chosen last. So this can occur 4 different ways. And the same thing happens with the men. So there's n choose 4 ways of choosing 4 men from n men, but the 4th man chosen is the leader, and it can be any one of these 4. So that occurs n choose 4 multiplied by 4 ways. So the total number of ways is n choose 4 multiplied by 4 multiplied by n choose 4 multiplied by 4, which equals n choose 4 squared multiplied by 4 squared, or 4 squared multiplied by n choose 4 squared. So it doesn't matter which order. Therefore, the number of ways of choosing an even number of people and then the leaders is 1 squared n choose 1 squared plus 2 squared multiplied by n choose 2 squared plus ... n squared multiplied by n choose n squared as required. Part 4. The process is now reversed so that the leaders, one man and one woman, are chosen first. The rest of the group is then selected, still made up of an equal number of women and men. By considering this reversed process and using Part 2, find a simple expression for the sum in Part 3. In this situation, the leader is being chosen first. So from the women, there are n ways of choosing a leader since there are n women in the club, leaving n minus 1 women to choose from to form the group. Similarly with the men, there are n ways of choosing a leader, leaving n minus 1 men to choose from to form the group. Using Part 2, there are 2n minus 2 choose n minus 1 ways of choosing an equal number of women and men after the two leaders are chosen. Since there are n ways of choosing a leader from n women, and n ways of choosing a leader from n men, this gives n squared ways of choosing a woman and a man leader. Hence, the number of ways of choosing a woman and a man leader and then an equal number of women and men is n squared multiplied by 2n minus 2 choose n minus 1 ways, which is equivalent to 1 squared multiplied by n choose 1 squared, plus 2 squared multiplied by n choose 2 squared, plus ... plus n squared multiplied by n choose n squared. Question 14b, Part 1. Show that sine cubed theta minus 3 over 4 sine theta plus sine 3 theta over 4 equals 0. Starting off with sine 3 theta, that can be written as sine 2 theta plus theta. Then we have the sine of a compound angle, and expanding that, we get sine 2 theta cos theta plus sine theta cos 2 theta. Now we have the sine of a double angle here and the cosine of a double angle here. So expanding all that, we get 2 sine theta cos theta multiplied by cos theta plus sine theta outside of 1 minus 2 sine squared theta. Expanding the brackets, we get 2 sine theta cos squared theta plus sine theta minus 2 sine cubed theta. And expressing cos squared theta in terms of sine squared theta using a Pythagorean identity, that equals 2 sine theta outside of 1 minus sine squared theta plus sine theta minus 2 sine cubed theta. And expanding the brackets, that equals 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. So collecting the like terms, we get sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. The next step is to rearrange this equation by moving all the terms on the right hand side over to the left hand side. So 4 sine cubed theta minus 3 sine theta plus sine 3 theta equals 0. And the final step is to divide all the terms by 4. So therefore, sine cubed theta minus 3 over 4 sine theta plus 1 over 4 sine 3 theta equals 0 as required. Part 2. By letting x equals 4 sine theta in the cubic equation x cubed minus 12x plus 8 equals 0, show that sine 3 theta equals half. Substituting 4 sine theta for x in the cubic equation x cubed minus 12x plus 8 equals 0, we get 4 sine theta to the power of 3 minus 12 multiplied by 4 sine theta plus 8 equals 0. Expanding the brackets, we get 64 sine cubed theta minus 48 sine theta plus 8 equals 0. Dividing all terms by 16, we get 4 sine cubed theta minus 3 sine theta plus half equals 0. Subtracting half from both sides, so effectively moving this positive half over to the right hand side so it becomes negative half, we get 4 sine cubed theta minus 3 sine theta is equal to negative half. Multiplying all the terms by negative 1, we get 3 sine theta minus 4 sine cubed theta equals half. And from part 1, sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta, hence sine 3 theta equals half as required. Part 3. Prove that sine squared pi over 18 plus sine squared 5 pi over 18 plus sine squared 25 pi over 18 equals 3 over 2. From part 2, sine 3 theta equals half. Taking the inverse sine of both sides, we get 3 theta is equal to pi over 6, 5 pi over 6, 13 pi over 6, 17 pi over 6, 25 pi over 6, and so on. Dividing both sides by 3, we get theta is equal to pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and so on. Now 4 sine pi over 18, 4 sine 5 pi over 18, 4 sine 13 pi over 18, and so on are roots of the cubic equation x cubed minus 12x plus 8 equals 0, but the roots need to be distinct. Now 4 sine 5 pi over 18 is equal to 4 sine 13 pi over 18, since 5 pi over 18 and 13 pi over 18 are supplementary. This is a quadrant 1 angle, this is a quadrant 2 angle. Also, 4 sine pi over 18 is equal to 4 sine 17 pi over 18 for the same reason. Hence, 4 sine pi over 18, 4 sine 5 pi over 18, and 4 sine 25 pi over 18 are distinct roots of the equation x cubed minus 12x plus 8 equals 0. Now the sum of the square of the roots, so it's alpha squared plus beta squared plus gamma squared, is equal to alpha plus beta plus gamma all squared, minus 2 outside of alpha beta plus alpha gamma plus beta gamma, and that's equal to negative b over a all squared minus 2 multiplied by c over a, and that equals 0 squared minus 2 multiplied by negative 12 over 1, and that equals 24. Hence, 4 sine pi over 18 all squared plus 4 sine 5 pi over 18 all squared plus 4 sine 25 pi over 18 all squared is equal to 24. So this is our alpha, this is our beta, and this is our gamma. So expanding the brackets, we get 16 sine squared pi over 18 plus 16 sine squared 5 pi over 18 plus 16 sine squared 25 pi over 18 equals 24. Dividing all the terms by 16, we get sine squared pi over 18 plus sine squared 5 pi over 18 plus sine squared 25 pi over 18 equals 3 over 2 as required.